Vectors on an inclined plane. So this is a very common problem in physics, but we're going to kind of just look at the math of it. So here we have the inclined plane and we have our axis rotated. First step will be to extend the downward vector to intersect the base of the ramp at 90 degrees. So we've done that here, we have 90 degrees. Our second step will be to find all the angles of this resulting triangle. So we have a 90-degree angle and a 40-degree angle, which gives us 130. So this angle must be 50 since the sum of the angles of a triangle are 180 degrees. Next, let's draw the vector projections on our rotated axis. So hopefully you're comfortable enough to realize you can kind of draw this axis anywhere. So let's just add it as the legs of our triangle. So f of y is our vertical component, our y component, and f of x is our x component. Notice this is 90 degrees, which means that this must be 40 degrees. Some people memorize that should go there, but it's good to understand it. So now let's use trig functions. So let's use our SO from SOHCAHTOA. Let's label our legs, opposite, adjacent, hypotenuse from our 40-degree angle. So opposite is f of x, and the hypotenuse is 250. Let's multiply both sides by 250. That will give us our x component into our calculator. 250 sine our 40-degree angle gives us 160.6969024. Let's round that to 2 decimal places. Always ask your instructor on what rules to follow. Let's use our ka from SOHCAHTOA, so that's our cosine of 40, adjacent, which is our f of y over 250, our hypotenuse. Again, multiplying both sides by 250 will give us our y component, 250 cos of 40. Gives us 191.5111. Let's again round that to 2 decimal points, and here are our components. You can kind of match that up here. Our f of x is smaller than our f of y, which makes sense for what we got.